recording. Okay. Okay, so today we're doing solving linear systems by graphing. Woohoo! Yay! No. Can you graph a line? Yes, it's a microphone. Okay. So our goal is to solve systems by graphing. Yeah, you're in your little. I know. I didn't want to say that. You know, I didn't want to offend anybody else. I could say that to you, but I don't want to offend anybody else. What? Go back. Solve systems by graph. Yeah, it's the same thing. It's section 3.1. It's Dalton. We'll just cover the microphone when I don't want to talk. Dalton, ready? Okay. So I in the book, and sometimes people are always asking me why do we do this. So they have little reasons why that you may do this. So I'm going to start adding this into our lesson, so you know there's actually an application in the real world for this stuff that we're learning, instead of just me making you learn it just because you have to learn it for high school and then you'll never use it again. So, right? So we compare swimming data as in problem 39. I did not like problem 39, or else I would have assigned it to you, because we have to have a graphing calculator, and most of you don't have a graphing calculator yet. So I didn't assign it. They are expensive, but you're going to use it now and in your next math class and in college. So it is an investment in your, it is an investment in your education. Okay? Especially if you're a freshman in this class, you really need a graphing calculator. Well, we have about 5 or 6 of them in here. Okay, everyone ready? Okay, so we're going to graph. And um, if you guys want, I made these. You guys have used them for homework, but you can cut them out, put them in your notes instead of drawing on graphs. So they're utterly interchangeable. Yeah. I do have blue. Imagine that. Okay, so we need to graph this. It's 2 lines on the same graph. That's all we're going to do is graph 2 lines on the same graph. So I always say line 1 and line 2. Yes, I have teachers. Can we do that like after the lesson? Are you guys okay with that? Okay. Okay. So for line 1, is it in the correct form to graph? What do I need to do? Subtract x. Good. And I get y equals negative x plus 4. So what's my slope? Negative 1 over 1. What's my y-intercept? 4. Okay. Then where do we start? We go up to 4. 1, 2, 3, up 4. And then I go down 1, over 1, or up 1, back 1. And my little thing is over here, which is good. Okay. I want to, when you're graphing this, when we're doing this, it is very important to make sure your lines are straight and go through where they're supposed to go through when we're doing systems, okay? because the answer is where the two lines cross. So if for some reason your lines are not in the right place, you're going to get the wrong answer. So you really need to make sure you're using some sort of straight edge when you're graphing these. And make sure you're using some sort of graph paper, not just drawing on your paper and making little hash marks. Okay? So be very careful when you're graphing linear systems. Everyone okay with that? Okay. So is line 2 ready to go? And then you go up 1, over 1. No, up 1, back 1, or down 1, forward 1. So line 2, can you guys see the green back there? You can see the green? Okay. Line 2 is 2x plus y equals 5. So what do I need to do? And I get y equals negative 2x plus, and my slope is negative 2 over 1, or 2 over negative 1. Okay? And my y-intercept is what? 5. What part is it? This one right here when I did the or? Okay. Well, if my slope is negative 2 over 1, right? This says I can go down 2, forward 1. But it can also be positive 2 over negative 1 and go up 2 and back 1. Okay, so I can write it either way. The negative just has to be with one of the numbers. Does that make sense? Are you okay with that? There's two ways to write slope for every one. Every time you write slope, there's two ways to write it. Okay, so I'm going to go up 5, and then I'm going to go down 2 over 1. Ooh, we already know what that is. Up 2, back 1. Draw a line. I guess we'll use red this time. Okay, and our answer is where the two lines cross, which in this case is where? 1, 3. Can you guys see the pink back there? Okay. Yeah, but this is where the two lines what? Intersect. That's the answer. No. We always go x first, side to side first. So I went over 1 and up 3. Okay with that? Okay. Everyone okay with this? Not bad? Right? This is just graphing two lines on a single graph instead of one line on a single graph, right? And then seeing where they intersect. So, okay, you guys go. Oh, I'll give you a few minutes to work on it, and then we'll come up and do it. Okay, so let's go ahead and do this. Line 1, line 2. Subtract x from both sides, and I get negative y equals negative x plus 5. Divide by negative 1, and y equals x minus 5. So my slope is 1 over 1 or negative 1 over negative 1. And my y-intercept is negative 5. No, you don't always have to put the or. But yeah, because a negative divided by a negative is a, and my slope is positive. Oh, when you're dividing? Yeah. Yeah. Because a positive 5 divided by a negative 1 is a negative 5. Right? Everyone okay with that? No, the x was negative, and it became what? Yeah. Okay. Everyone okay with that now? Okay. So I go down 5. 1, 2, 3, 4, 5. Okay, so there's line 1. And then line 2, we have 2x plus 3y equals 0. Subtract 2x, and I get 3y equals negative 2x. And I know that some of you put plus 0, which is fine, but do I have to put plus 0? No, right? So y equals negative 2 thirds x. So my slope is negative 2 thirds or 2 over negative 3. And my y-intercept is what? 0. Good. Okay, so I'm going to start at 0, and I'm going to go down 2 over 3, or up 2, back 3, and then I'm going to draw a line. Yes, it's negative 2 over 3. Sorry, negative 2 thirds. So it's negative 2 over 3 or 2 over negative 3. Oh, the answer? Sorry. And the answer is right here, which is 3, negative 2. How far do I go to the side? And then how far do I go down? Right? Okay. Everyone okay with that? Manuel? Good? Okay, Maria. I'm going to get it right one of these days. Yes? The point of intersection. The point where they intersect is the answer, by the way. So I went 0. Yeah, well, it depends on which one I use. I went down 2 and forward 3 on this one. And on this one, I went up 2 and back 3. Yes, yeah, because my y-intercept is what? 0, so I start there. Yeah. Only if my y-intercept is 0. I always start at my y-intercept, wherever my y-intercept is. Is that okay, Carla? Okay. Everyone okay with that one? Oh, sorry, Jose. I'm holding. Yes, do you have another question? Okay. I don't remember what I called it. Okay, Jose, we good? Your turn. It's your turn. Yeah. Graph. Yeah. Right there on your paper. Big question mark. You're influenced. You're bad influence. You already know this. Anybody have an answer yet? Good. Nice. So I have line 1 and line 2. So they're already in slope intercept form. So line 1, what is my slope? And my y-intercept? 2. So if we graph it, we go up 2, up 3 over 1, down 3, back 1, line. And then line 2, what's my slope? 1 or -3 over -1. My y-intercept is -2. Great. So I'm going to go down to -2, 3 over 1, back 1, draw a line. Okay, so what is my answer? No, you're right. No solution. Why is there no solution? Because the lines never intersect, right? Ever, ever, ever. Some people argue like way out in space, a million, zillion miles away, they may intersect, but we're not getting into that, okay? So, because light bends, so the lines might bend and blah, blah, blah. Okay? So, no solution. Great. So now I have one solution or no solutions to my problems. Next problem. And I think the last problem. So that means you may be able to get homework done in class, which means no homework. Wouldn't that be nice? I know. If you get your homework done in class, no homework. That's so nice. let's go ahead and do this. Okay. Yes. Are you sure? Okay. So I'm going to go ahead and start with line 2 since it's already in the right form. Is that okay with you guys? What's my slope? Wrong. -3/4 or 3/-4. What's my y-intercept? 3. Okay, so I'm going to go up to 3. 1, 2, 3. And then I'm going to go down 3 over 4, 4, or up 3 and over 4. Draw a line. Try and get it where it's supposed to be. Yeah, I did line 2 because it's already in the right form, so I just went ahead and did that one first. Is that okay? And it's easy to do because it's in slope-intercept form, right? Okay, so if we do line 1, now I have to solve. So subtract 3x, and I get 4y equals -3x plus 12. Divide by 4. Y equals -3/4 x plus 3. Oops, wrong one. Exactly the same. Okay? It's the same line. So how many solutions do I have? Ooh, how many is a lot? Yeah, infinite. Infinitely many solutions. Uh-oh, I'm going to spell it wrong. Infinitely many solutions. Okay? Infinitely many solutions. So you have 3 options. If they're the same line, I have infinitely many solutions because every point on the line they intersect, so every point is a solution. We have where they're parallel, where no points intersect, so there's no solutions. And then we have the most common is where they intersect in 1 point. And that would be our answer. Okay, any questions? Yes, IMS means infinitely many solutions. As long as you know what IMS means. What? You don't understand how I... Honey, look at the equation here. Okay, and then look at the equation here. They're what? They're identical. Okay? Because you didn't do this part right. Okay? All right. Are we okay, Carla? Okay. Any questions? Everyone good? Okay. So we solved them by graphing. Woohoo, yes, we achieved it. I put this in because some of you may need help, and this is not from our book. This is from the book I used in middle school for algebra. And if you need help, you can go to here, phschool.com, put in this code, and it'll be a little tutor video that will show you how to do it. So if you want to write this down and think you may need help doing this, you can. But you should have enough time to get the homework done with help with me, right, if you need help. But I'm going to leave that up there. If I have that option to put this on here, I will. Not all the lessons, of course, I'll be able to do that on, but because this is almost the identical lesson I taught algebra, I can do this. Yes, I taught you this lesson. Actually, not exactly this one because it was a different book, but it was the same lesson. Different problems. Everyone good? Oh, hold on. Somebody said no. Oh! Having a rough time today, obviously. Done? Okay, great. So homework, page 156, 4 through 30 even, 36 and 37. and a reflective journal. So it's like 15 problems. I know, and you have 45 minutes to do it in. So that's like 3 minutes per problem. I will warn you right now, the last two are story problems. Okay? Attempt them. Read them. Oh my gosh, don't look at the words and say, oh, it's a story problem, I can't do it. Please try to read the problems and attempt to do it, okay? Yes, I do. Do you say I hate math and I don't like this? Yeah, I read it all. I read all that stuff. Well, some people say hi, and some people say I love math. Some people actually ask questions about math. Some people write quotes on there that are, part of their manifesto. Um, Graphene, linear systems of linear equations by graphene.